We have been talking about slope and rate of change, and they basically mean the same thing, so just really fast here. We talked about finding the slope, which is the letter we use for slope is M. All right, finding the slope, we started out and saying, hey, it's a ratio, it's a fraction, and if we have a graph, we need to look at the vertical change, which we called what? The rise. Very good. We got the rise over the run. Very good. So we had the rise over the run. That was the vertical piece over that horizontal stair step that we were making on Friday. And then yesterday, we also looked at the formula. Yeah, sign up. The formula we had from yesterday was, what if we don't have a graph that's easy to count, right? So what if what we have is, the numbers are just too big. I can't count 100 little riser things. Like, I can't do that. That's ridiculous. And so we said, hey, can't we just subtract the y? Because the y-axis is that vertical axis. So all we have to do is subtract the y, which was y2 minus y1. And then to get the run, that's that horizontal piece. And that's just like that horizontal axis, our x-axis. So we can subtract our x values, x2 minus x1. And so that's what we did the last couple of days, and that's just looking at slope, which is also rate of change. So these all mean the same thing, and we have a couple of ways that we can do that. So we're going to keep talking about slope or rate of change. We want to be able to determine the rate of change of real-world questions, which is kind of nice to talk about. So here we have the table below shows the high temperatures in degrees Fahrenheit of a city during the first part of June. So this would be June 1st, June 6th, June 8th, June 14th. And the high temperature was 72 degrees on the 1st, that sort of thing. It's really important. Most problems like this you guys come across when you're testing, they're actually really easy. And if you just read carefully, then it goes pretty well. So they've given us this table. We want to find the rate of change. And again, rate of change is just fancy for slope. So we really just want to find the slope, the rate of change of the high temperatures between June 1st and June 6th. So I'm looking at these couple of dates. Well, guess what? They've given us a table. And that table is simply ordered pairs. All right? We have our x's and we have our y's. The date, the time is that x variable, and the temperature is the y variable. And so what I can do is I just have ordered pairs. I want the first ordered pair, June 1st. Well, that was a 1. What was its output from our chart? 72, yeah. So there's one ordered pair. And what's my second ordered pair I'm going to use? From June 6th, what's the ordered pair I should do? Yeah, right there. June 6th had a high of 76. So we went 6, 76. So we have 2 ordered pairs. And if I have 2 ordered pairs, I am just going to go ahead and find the slope just like we did yesterday. So really, we just are practicing a little bit more. What is our slope? And just like yesterday, I'm going to circle my y values to help me identify them, and all I have to do is subtract them. So I'm going to start with my second ordered pair, 76, and I'm going to subtract the 72. And then underneath, we have the x values. So I'm going to start with the 6, my second order pair, so starting with the 6, and I'm going to subtract the 1. That's all we're doing, just like yesterday. All right, we've got ordered pairs, and we can figure all them out. What is 76 minus 72? 4 over 5. 6 minus 1 is 5. And so, well, that sort of maybe doesn't make a whole lot of sense. What does that mean? Let's talk about that. We were talking about this was 76 degrees, and this is the 6th day minus the 1st day, And so what we have here is 4 degrees per 5 days. We're talking about the units, really, is what we're talking about here. And maybe we want to make that a little more understandable. So I'm going to go ahead and just divide 4 divided by 5, and I get 0.8 degrees per day. I don't think you're really going to have to do that on Delta Math today, but these are the units Delta Math has written in already, like degrees per day. So we're going to talk about, I'll talk more about that here. Now, letter B, find the rate of change. What does rate of change mean? Slope. It's just the slope. In the high temperature between June 6th and June 8th. All right, I'm using June 6th and June 8th. What are my 2 ordered pairs then? Good. So June 6th was right here, and its ordered pair would be 6 and 76 degrees. So that's day 6, and it was a high of 76 degrees. And what's my second order pair that I'm going to use? From the 8th, we have 8. That's day 8, and the temperature was 84 degrees. And so again, I want to figure out the slope, and I'm just going to use my 2 order pairs. What am I going to subtract first? The y's, yeah. I'm going to start with 84, and I'm going to subtract the 76. And those are degrees. 84 degrees minus 76 degrees. And then what goes on the bottom? Yeah, my x values. My 8, day 8 minus day 6. And those are days. All right, what is 84 minus 76? Mm-hmm. 8 degrees. So that had a change in those 2 days of 8 degrees in the high temperature. And then that's 8 minus 6 is 2 days. So the temperature went up 8 degrees in those 2 days, but that's a little bit weird. I want to go ahead and reduce that. What is 8 divided by 2? 4. So it becomes 4 degrees every day. That's what rate of change is talking about. What is the change in the temperature each day? All right, so it went up 4 degrees, and then another 4 degrees the next day for that total of 8 degrees difference there. Part C says, during which of these time intervals did the temperature rise faster? Yeah. Here, between the 1st and the 6th, our temperature only went up 0.8 of a degree each day. So it was like almost 1. So it went up from 72, not quite 73, not quite 74. It just went up a little bit each day. On here, between the 6th and the 8th, we went up 4 degrees. We started at 76 degrees, and then it went 4 degrees more the next day, and then it went another 4 degrees more the day after that. So this one, between the 6th and the 8th, that temperature was rising a lot faster. Does that make sense to you? Okay. So the temperature rose faster between June 6th and June 8th. The temperature rose faster between June 6th and June 8th. So all I'm doing here, and Delta Math is actually even easier than this, they give you a table of values, pick 2 points, find the slope. That's what you're doing in Delta Math today. It's super easy. Let's turn the page. So the first one, they presented things to us in a table format, an XY table. All right, so you're going to see the same thing in Delta Math today. You're going to have a table of values. Find your ordered pairs, subtract your y's, subtract your x's, easy peasy, okay? Here we have our information presented in a graph. The graph below shows the number of miles driven after each hour of a road trip. So let's make sense of our graph that they've given us here. We have hour 0, and then here we have hour 1, the second hour of a trip, and the 4th hour, and the 8th hour, and the 10th hour of a trip that we're driving. And this is the number of miles driven. So after the first hour, how many miles did they drive? 60, sure. And at 4 hours, how many miles did they drive? 160 miles, absolutely. So they were moving pretty slow, actually. All right, so letter A, we want to find the rate of change. What does rate of change really mean for us? Slope, it's just fancy for slope. From hour 1 to hour 4. Well, if I need slope, I need 2 ordered pairs. What are my 2 ordered pairs that we're going to use in this problem?
1 and 60.
Yes, 1 and 60. That's miles. 1 hour. 1 hour has 60 miles. Okay, what's my second order pair? For hour 4? Yeah, the 4th hour had an ordered pair of 160 miles. So 160 miles. All right. So I'm just keeping my units on there. And then I can go ahead and find my slope. My slope is a fraction. What am I going to subtract first?
160.
Yeah, 160. 160 miles minus 60 miles. So 160 miles minus the 60 miles. That's what I wrote down there on top. What am I going to write on the bottom?
490.
Yeah, 4 hours. 4 hours minus 1 hour. So subtracting my y's and subtracting my x's. All right, what is 160 minus 60? Is it? It's 100, yeah. So 100 miles. Good. And then on the bottom, 4 hours minus 1 hour? 3 hours. Good. And I'm going to clean this up a little bit. So let's see. Because 100 miles in 3 hours doesn't make a whole lot of sense. That's not usually how we see miles per hour. So I'm going to go ahead and divide to figure out my unit rate here. So that is 33.3 repeating miles per hour. Miles per hour. Miles is on top, hours is on bottom, so we say miles per hour. Okay, doing okay? Yeah, it's just slope, right? Let's look at letter B. Find the rate of change from hour 8 to hour 10. What are my 2 ordered pairs? Ooh. Boy, this one requires some figuring out, yeah? Let's see. So I want hour 8. So hour 8 is right here. I need to figure out what that ordered pair is. How high is that? I don't really know. How can we figure that out?
Probably like 410.
How'd you get 410? Oh, yeah. Let's see. But this is, yeah, oh, interesting. Oh, there's a squiggle there. Do you see that little squiggle? I'm just noticing it. Do you see that little squiggle? That little squiggle is a break in the graph. And so it is a different scale than everywhere else. But you're right. Between 60 and 160, that's 100. And so then each box must be 50. So you're right. So this would be up 50 would put me at 110. Up another 50 would put me at 160. And so you are right. Let's go between here. We've got 100 between the two. We're going to split it evenly. So each thing should be 50. So 360 plus 50 is 410. Good job. And another 50 would put us at 460. So yeah, you got to do a little figuring there. So that's 410 miles. And what's my second order pair? Uh, 10 hours. Yeah, 10 hours. That's here at 10 hours, and that's how many miles was 460 miles. Excellent. So again, I'm just finding my slope, and I'm going to subtract 460 miles minus 410 miles over 10 minus 8. 10 hours minus 8 hours. Excellent. Let's see. 460 minus 410 is 50 miles. And 10 minus 8 is 2 hours. Which is what? What does that clean up to be? 25. Yeah, 50 divided by 2 is 25 miles per hour. Oh my God. They must have been in a blizzard. 25. That's what we were driving. We went to Iowa for Thanksgiving 2 years ago. We had a really bad snowstorm over Thanksgiving. And we were driving home in that snowstorm. And we literally went from Grand Rapids to here at 25 miles an hour. Because it was so bad. It took forever. So 25, that's really slow. That's school zone speed or residential neighborhood speed. So that's really, really slow. Yeah, that is okay. All right. Do you guys have questions for me so far? No? Okay. Let's just look at number 5. Number 5, Ava started a savings account with $500. After 6 months, her savings account was $731. We want to find the rate of change. And again, when we have rate of change, it's just talking about slope. We need some ordered pairs. So I'm going to have 2 ordered pairs again. And what are those ordered pairs going to be? We have dollars and we have months, yeah? So what happens when you start something? How many months have passed? 0 months. So when you start something, it usually means you're at 0, starting at 0. And then we have, what was her balance when she just started her account? $500. So we're going to have money. So our independent variable, our X variable is time, and then we have money. And then what's our second order pair? 6 months. And then 731 buckaroos. And again, we're just finding the slope. So what are we going to subtract here? Yes, 731 minus the 500, and that's money. Money's on top. And then what are we going to go on the bottom? 6 minus 0 months. All right, we're talking about time on the bottom. All right, 731 minus 500 is 231 over 6. That's $231 in 6 months. And again, that is a little bit weird to think about. So I want to find the unit rate. So when we have just 1 month, not 6 months, we're just going to go ahead and divide. 231 divided by 6 turns out to be 38.5, or that's money, right? So $38.50 per month. So she was making about $40 a month. Okay. Do you guys have questions for me? No. All right. You guys are basically figuring out slope today.